Let us see this few problems of moment of inertia for NEET. इसमें दिया है there is a L-shaped frame with uniform density. Each side have length L, mass M, and in the plane of the frame there is line passing from the junction. This line is making angle theta from one rod. We have to find I about this rod. This type of question was asked in JEE Mains by NTA this year. So here we should remember that if we have a rod and it is making angle theta from certain line, then above that line its moment of inertia will be ml square by 3 sine square theta, and you can verify it by, if you take theta 90, then you can realize that this line is perpendicular to this rod and passing from the end of the rod, and about the end of the rod has moment of inertia 1 square by 3. So if you place theta equal to 90, you will get the correct answer. So if you apply that relation, then you should get ml square by 3 sine square theta, and this angle will be now 90 minus theta. So for other side it will be ml square by 3 sine of 90 minus theta square, that means cos squared theta, for the same logic. So it will be equal to ml square by 3, right? And similarly, if we apply the same concept here, we have a uniformly dense frame of a square shape. Each side has length L, each side has mass m by 4, so that means total mass is m, and apply same logic. So for one side you have this angle 45. So for one side about this diagonal, I will be m by 4 L square by 3 sine square 45, m by 4 L square by 3 sine square 45. And since there are identical 4 sides, each side is placed identically with respect to this diagonal. So answer should come out to be equal to ml square by 6. And about this square, we have to find I about this axis, where square is of uniform density, side length L, mass m, and this axis is perpendicular to plane of the square. So how to get this one? This answer should be 2 by 3 ml square, and same answer will come out in this case. It is uniformly dense cube of mass m, side length L. We have to find I about this edge, about any edge, and here also you should get answer 2 by 3 ml square. Let us understand one of these two. They are identical. If you can realize this one, this will automatically obtained. This side is perpendicular to sheet. What we can do, we can apply first perpendicular axis theorem, and first find the moment of inertia about these two axes which are in the plane of the sheet. And if we could find these two I, we add them by perpendicular axis theorem, we will get I about this, right? And to find I about this area of the side, you can think like this sheet is made of so many thin rods. Each rod has same length of mass m1, m2, and so on. So about this line, moment of inertia will be m1 L square by 3. Okay, this is ये rod का end है इसका. m2 L square by 3, m3 L square by 3, m4 L square by 3. So we will find about this axis ml square by 3. Similarly, we will get ml square by 3 about this line. So add these two I using perpendicular axis theorem, we will get I about this axis which is perpendicular to this sheet and these two axes. You will get 2 by 3 on a square. And how to get this one? Let us first realize if we place so many square sheet in layers, we will get a cube, right? We will get a cube. And this now axis is acting like edge of this type of cube. So moment of inertia about this will be given by the same formula, because each layer has same expression for I. Only thing is that mass will be distributed, but if you distribute m1 of this layer, m2 of other layer, m3 of other layer, and L is same, so if you add, you will get total mass added up and then 2 by 3 and L square. So if I am asking about this edge, you can say it will be same as about any other edge, and since this example we have, so it is better to find about this edge. You can easily feel it, right? The moment of inertia of Q about edge has been asked in many exams many times, right?